Thank you very much. Good morning, everybody. We have around 50, almost 60 people online, just a few more attendees that will be joining. I'm going to give it one more minute out of respect for everybody who's joined on time. Thank you very much. I know Gugu and the team from the South African Institute of Mining are just moving everybody from attendees to panelists. We'll give them a minute to do that. The reason you're moving to panelists is we want you to be able to engage with our speakers today, to be able to ask questions. I just ask that you keep yourselves on mute while we're continuing, in case your cell phone rings or your wife comes in, whichever one, you'll just let us know. My name is Leandra Chinia. I am the Marketing Director for Huawei South Africa for the enterprise business. I am based out in Johannesburg, and I am happy to be your host today. The rose amongst the thorns. All the guys will be the speakers, and I will be hosting them. I think we just have 2 more minutes. Gugu, do you want to just bring everybody over to the panelist side, please, and then we'll get started. I want to start by sharing my screen with you. Someone can give me a heads up that they can see?
Yes.
Yeah, okay, good. So good morning, guys. Like I mentioned, my name is Leandra Chinia. I'm the Marketing Director for Huawei. Thank you for taking the time to join our webinar today, together with the South African Institute of Mining. For those of you who don't know us, Huawei Technologies was founded in 1987. Huawei is a leading global provider of information and communications technology infrastructure and smart devices. We have around 197,000 employees, and we operate in around 170 countries and regions, serving more than 3 billion people around the world. In specific, you'll meet some of our Huawei staff who is actually from Germany joining us today, and I'll introduce you in a little bit to him. Huawei's mission is to bring digital to every person, home, and organization for a fully connected, intelligent world. To this end, we will drive connectivity and promote equal access to networks to lay foundation for the intelligent world. I wanted to talk to you guys a little bit about mining, and this is why you've joined. An extraordinary year has passed. What we like to call 2021 is going to be the year of digital transformation. The digital journey of mining needs proactive promotion of modern technologies and our latest solution resources for the mining industries, accessible and available anytime, anywhere. From business, technology, and other dimensions, together with global mining administrators and heads, which is some of the speakers you'll meet a little bit later on. We're going to explore innovative technologies that will accelerate the digital journey of the mining industry in South Africa. So I want to stop sharing my screen. Sorry, just give me a second. Okay, so we'll carry on. It's estimated that South Africa holds an estimated 35 trillion rand worth of mineral resources, which are yet to be exploited. Despite this mineral wealth, the country has in recent years not attracted sufficient investment to allow for new mines to be opened or for substantial exploration campaigns to be carried out. On the importance of South Africa's mineral wealth, the 2021 budget tabled by the finance minister stipulated that mining was the only sector that grew in revenue by 40% in the financial year. In addition, royalties were up by 21%. These numbers give you an idea that the mining sector in South Africa is not just for the benefit of stakeholders, but it actually exists for the benefit of the entire country. So on the road to digital transformation, together with our partners, such as the South African Institute of Mining, we're all hoping to achieve a fully connected, intelligent South Africa. We have some exciting speakers. Our first speaker, I'm very honored to introduce you to Mr. Ulrich Kraf. Mr. Ulrich is the Senior Engineer in Industry 4.0 and Industrial IoT at the Huawei German Research Center in Munich. Before joining Huawei in 2011, he worked almost 17 years in the telecommunication industry in various sales, product, and R&D departments at Siemens and Nokia, where he could extend his business and professional competence in the areas of engineering, product and program management for enterprise, fixed and mobile networks. So since joining Huawei, Ulrich has established in the European solution management team, serving solutions like policy traffic management, cell congestion, control, telco transformation, and more recently, Industry 4.0 and IoT. In 2009, Ulrich joined the Applied Network Technology Laboratory in the Huawei German Research Center in Munich, working on new communication and networking technologies, targeting different industry verticals. Thank you, Ulrich. I think you've shared your screen already. I'll hand over to you.
Yes, thank you very much for the introduction and welcome to everyone. I have the honor to have the first speech about how ICT tech innovation brings digital transformation to the mining industry. As introduced, I'm here working in Munich in Germany in the Research Center for Applied Network Technology Laboratory. And besides that, I'm also a member of the Platform Industry 4.0, specifically the Workgroup 1, Reference Architecture Standards and Norms. And I'm also, since beginning of this year, co-chair of the mining task group of the Industrial Internet Consortium. That means that I also borrowed some slides and concepts from Platform Industry 4.0 and also from the Industrial Internet Consortium for my team. Yeah, first of all, the fourth industrial revolution, what we actually mean. We see a lot of buzzwords, technologies like here, cloud edge computing, smart services, cyber physical things, big data analytics, artificial intelligence. But the underlying theme for my presentation will be all connected, all sensing, and all intelligent. Specifically because we have different stages for Industry 4.0 development. In the first two stages directly related to digitalization, which is computerization and connectivity. So the first two steps rely to all connected. Then we have also part of Industry 4.0, what is happening, so why the visibility, here underlining all sensing. And then finally the stages 4, 5, and 6, why is it happening, what will happen, and how can an autonomous response be achieved by all intelligent. So for the first part of my presentation, all connected, I provide here the Industrial Internet Consortium framework, specifically the connectivity framework, which provides some selections for the upper layer networking technologies, meaning transport, framework, and distributed data management and interoperability. Here we have technologies like DDS, 1M2M, Lightweight M2M, W3C, and OPC UA. Here in the Industrial Internet Consortium, you can check all the details in the Industrial Internet Connectivity Framework. And I'm, as already outlined, I'm also a member of the Industrial Internet Networking Task Group, which is currently soon to be releasing a framework for the networking part. And here we are looking on the lower layers of the stack, which means Internet Protocol, and also then the link and the physical layer means wireline technologies like Ethernet, IEEE 802.1 or 802.3 for the physical layer, specifically new technologies like time-sensitive networks or real-time networks, and then a bunch of wireless technologies, specifically here wireless personal area networks, so things like Bluetooth, Zigbee. We have a wireless local area network, specifically currently top-notch the Wi-Fi 6 technology, Then cellular technologies specified by the 3GPP standardization, more specifically the most recent entry here, the 5th generation of mobile networks, and then also the 802.16 from IEEE. For the Wi-Fi, we see here how the Wi-Fi technology evolved in the past 10 to 15 years, with the mainstream from Wi-Fi ABGN towards the AC1 and AC2 Wi-Fi, towards Wi-Fi 6, also called 802.11ax. But besides that, we have also the WiGig, which is utilizing 60 gigahertz for room desk area networks. We have also related to machine type communication, machine to machine IoT for the Wi-Fi AF and Wi-Fi AH. And last but not least, we have also Wi-Fi for connecting vehicles and vehicles to infrastructure, like the 802.11p Wi-Fi. So what is Wi-Fi 6 capable of? I also introduced here Wi-Fi 6E, which utilizes, besides the 2.4 and the 5 gigahertz frequency band, also the 6 gigahertz frequency band, which means by local regulators that for Europe we have doubled almost the available spectrum for Wi-Fi 6E, which means we get extra 480 megahertz. And in the US, they get up to 7.2 gigahertz. That means they get another 1,200 megahertz in the US. That means we have much more spectrum. We have much higher throughput. Here, maximum of 9.6 gigahertz per user. We have very low latencies, something like 10 milliseconds, and we can connect 1,024 users to a single access point of the network. Here's an example, specifically Wi-Fi for underground mine, underground Wi-Fi 6 network solution, which accommodates from face to tip. Here we utilize Wi-Fi, the latest and greatest in Wi-Fi 5 and Wi-Fi 6 for coverage. We connect all the remote units or the antenna units by means of power over Ethernet. We have also other technologies which could be put into the access points, like Bluetooth, Zigbee, and RFID. That means seamless roaming connectivity for underground moving devices. 3D simulations resolve coverage holes problems, and we can have up to 20% coverage improvements and flexible deployment and wireless coverage for the underground mine. So the values here is the visibility of production, personal and asset performance, facilitating proactive management and interventions and decision-making. And we have reliable and integrated data sources for spares, assets, work scheduling, labor, improving planning and execution efficiency. Then we have the 5G connectivity, the wireless connectivity, specifically the most recent standardization release, which is 3GPP release 16, because in 3GPP release 15, only the evolved or enhanced mobile broadband was introduced, which can you see on top of this triangle, with a maximum throughput of 20 gigabits per second. But in release 16, we have also the introduced massive machine type communication here on the lower left side of the triangle, specifically scaling in terms of number of connected devices. So here we see in the next 5 to 10 years, 100 billion connected devices globally, IoT devices. And on the lower right corner, the ultra reliable low latency communication, which promises a latency round trip time down to 1 millisecond, which is important for remote control, self-driving, autonomous cars, and industry automation, for example. So for this industries, for industry automation, we see also certain user organization which drive the technology with industry-specific use cases. So for industry automation, this is the 5G Alliance for Connected Industries in Automation, and for the cars, we have seen the 5G Automotive Association. So all these kind of use cases and features are provided by a new air interface, which utilizes massive multiple input, multiple output, so antenna arrays, which also provide steering beams into certain directions where the user sits, and this provides flexibility and spectrum efficiency. For the core network, we see a complete new network architecture, one physical network providing or serving multiple industries. Here's another example for 5G connected mining vehicles, where we connect mining, so trucks and excavators. These are connected by cameras, sending the video feeds to a remote site, where then a pilot can do the remote control several kilometers away, can do the controls, send the controls back to the vehicle, and the vehicle then executes these movements. So this is here shown for excavator and also for mining trucks. Yeah, for that, besides cameras, you can also employ other sensors like radar, LiDAR, ultrasonic sensors to really see and make the environment of the vehicle visible in real time to the pilot. And we have for the all sensing, I give an example here of the digital twin. This became very popular in the, let's say, last 1 to 2 years. Digital twin is a digital representation sufficient to meet the requirements of a set of use cases. Here, digital representation means information that represents characteristics and behavior of real-world twin. And for the sensing, sensor data retrieved from real-world twin drives the representation of the digital twin in the virtual world. The digital model and logic of the digital twin provides visibility, transparency, and context awareness of the process. So we see directly what is happening and why is it happening. Here's just on the left-hand side example with a turbine, where we have on the left-hand side the real-world twin, and on the right-hand side the digital twin represented in the virtual world. With regards to Industry 4.0, the asset administration shell is defined, which is directly attached to all assets in the Industry 4.0 network, as shown here on the left-hand side. So the integration of assets into the world of information. Here, asset means everything that requires a connection for Industry 4.0 solution, which means machines and their components, supply materials, parts and products, exchange documents like drawings, wirings, diagrams, contracts, orders, anything related to this asset. So the asset administration shell is in that sense the implementation of the digital twin for Industry 4.0 networks. As stated, the digital twin is quite new, but here just some examples of certain organizations which drive forward the development of digital twins. On the columns, you see certain topics like general guidance, focus on digital twin, focus on manufacturing applications, open code, open specification, open development model. And on the x-axis, you see some examples of organizations taking care of digital twin. And we see the most complete of these organizations is the Industrial Digital Twin Association here, and another organization taking care of the digital twin is the Digital Twin Consortium. So this is just another example where you can see how the digital twin is developed. Then besides all connected, all sensing, we come finally to the all intelligent, means artificial intelligent. And here we see that sub topics of artificial intelligence are machine learning, deep learning, and neural networks. And here's just some examples how artificial is utilized by machine learning, for example, for predictive analytics, deep learning. We see here text to speech, speech recognition, image, computer vision, language, natural language processing, and then also certain expert systems, planning optimization systems, and connected robot. Just some of the examples how artificial intelligence is used by industries in a generic form. But what are the examples, the artificial intelligence examples in the mining industry? Here we have autonomous mining machines, stope phase assessment and reef profiling, so with image analytics, track and positioning of assets and people, identification, classification, real-time resource scheduling, allocation, and optimization, for example, fleets, to manage fleets, dynamic visualization and mapping of the underground layout, for example, by autonomous drones, evacuation in case of incident, so here estimation of risk level by artificial intelligence, and also then conveyor belt imaging, so for things like sorting, automatic image-based sorting. We give another example of the Huawei MindBrain artificial intelligence, which is improving productivity and safety. So here on the left-hand side, you see the architecture utilizing cloud for the training the algorithms, and then also the edge side at the mine, where you can do then after the training the inferencing. So to identify some objects on the left-hand side, for example, where you see that wood or certain obstacles are on the belt, and here you can immediately react and define actions to mitigate risks and problems in real time. So finally, here an overview of Huawei new ICT, building the intelligent mine. On the left-hand side, you see certain architecture, ICT architecture, utilizing all the topics I mentioned, like all connected, all sensing, and all intelligent for all operation scenarios here, like exploration and development, open pit mining, underground mining, mine transport, and mine process. We have lots of devices and communication interfaces, computers, gateways, handsets connected to the network. The network utilizes operational technology part, but also IT networking part by using certain customer premises equipment, access points, gateways, and so on. And finally, connecting via cloud platform for utilizing artificial intelligence, big data analytics, and also provide things like IoT platform management. Yeah, finally, Huawei ICT enabling the future of mining by industrial IoT, IT-OT convergence, cloud and edge computing, ubiquitous connectivity by means of 5G and Wi-Fi 6, artificial intelligence, machine learning, digital twin, and autonomous robotics and vehicles. Okay, that's it for my part. Any questions?
I think you did a really good job, Ulrich. That's why there's no questions right now.
I hope so, but I think we have lots of opportunities to also talk about the technologies and opportunities. Thanks.
Definitely. And I think, so we have, let's see, somebody's put their hand up from the panelists. You're welcome to unmute yourself. Mr. Musa, I see your hand is up.
Ulrich,
yeah.
Presentation, that's quite a good presentation. I have just one question. What do you think be the barrier to entry, or rather, to being received of these new technologies that we're trying to, bring into the mining industry? What could hold them back from being, accepted effectively, or for them to hit the ground running? What could be the barrier?
Yeah, first of all, I think if people are suspicious that artificial intelligence will replace people, but I think that's also a topic of the discussion, that here full transparency is needed, and finally it's not about reducing the number of workers and provide anything by full automation. That's definitely not the case, I think. So here it's important to be fully transparent, to have clear goals for the transformation, and also making the workers integral part of this transformation.
Okay, thank you, Ulrich. And I think our next speaker is also in a very good position to answer one of those questions. I see we have another question here, Ulrich. I think it's just one more for you. In terms of deep level mining, how effective is the use of Wi-Fi for existing old mines, thinking around cost and efficiency?
Yeah, I think it's perfectly also for difficult environments, because here we can also provide small cell networks. That means every few meters we can attach another access point to make sure that in all areas of the underground mine we have full connectivity. That means also a full coverage of the network. Also, as mentioned, in very difficult environments, like rock environment, where you have lots of interference. So here we have also technologies to mitigate interference and to provide full connectivity for the complete area.
Okay, all right, thank you, Ulrich. And I think that's also another good question that's posed perfectly for our next speaker. And some of you in South Africa are obviously familiar, the Mandela Mining Precinct. The precinct is a public-private collaboration between the Department of Science the Department of Science and Innovation and the Minerals Council of South Africa. It is an initiative aimed at revitalizing mining research, development, and innovation in South Africa to ensure the sustainability of the industry. Today, we're honored to have, and some of you may be familiar with Mr. Jean-Jacques Verhage, and we are also, he's warmly known as Mr. JJ. He is the program manager of the Real-Time Information Systems program at the Mandela Mining Precinct. JJ's career spans 30 years, several industries, and multiple geographies. He's a globally certified project management professional and a new product development professional. Mostly in senior positions, he has served in ICT, governance, management, and technical, and has often delivered on large, complex, globally spread projects spanning the Europe, Middle East, Africa, and Asia Pacific regions. JJ has worked in numerous industries and currently serves as the program manager for real-time information systems, also known as RTIMS, which delivers R&D innovation in and for ICT, digitalization, the industrial Internet of Things, data and information management in mining. For the Minerals Council South Africa, and is primarily based at the Mandela Mining Precinct. The aim is to assist in bringing the South African mining industry up to speed in terms of 4IR technologies, and JJ has embraced this challenge and embarked on it since 2017. Thank you, JJ, over to you. I think you're on mute.
Excuse me, Leandra.
Thank you, Leandra.
Sorry, this is Dawie Fourie speaking.
Yes, hi, Dawie.
Are you well?
Yes, thank you.
Right. Just a question. We are an underground mine near the Mpumalanga province of South Africa. I've seen now, you know, your whole Wi-Fi structure and everything. The question that I have is that how do you prevent cyber or hacking, you know, you know, you've got a lot of end devices running through your Wi-Fi's, and nowadays we see that the industry vulnerability is hacking your OT environment, gain access to your plant or whatever, and then shuts down those, you know, industry machines. So now, how do you safeguard your multiple different devices, and how do you prevent from hacking or getting vulnerabilities? Or just in short, how do you treat cybersecurity in that sense?
Yeah, that's a very good question, Davi. Thank you very much. I'm just going to ask that we park it. We have a panel discussion in just a few minutes where we'll have some of the Huawei experts, some of our different heads here, and yours will be the first question I pose to the panel, if you don't mind.
Okay, no, 100%. Thank you.
Okay, great, thanks. Back over to you, JJ.
Thanks, Leandra. So I'm going to jump straight in. If I can get my slide moved. Right, so many of you do know who the Mandela Mining Precinct is. It started in 2017 and was officially launched the year later. But the ARTIMS program, which stands for Real-Time Information Management Systems, was launched back in April 2017. And initially, the mandate that we received from industry was to focus on real-time and underground communications, especially in the environment of hard rock and narrow reef mining, specifically platinum and gold. And the belief was that, or is that, and it still holds, is that if we can sort out problems relating to real-time communications and that backbone system, especially at the stope area, then we can make many other things possible. So that's how the journey started, and but we did not neglect to focus on the other components that would typically go in an effort like this. And so not solely focused on the networking side of things, but as well on data, on modeling, visualization, on standards, on the sensor network, etc., including cyber security, just to answer Davi's question. But more information can be found on the Mandela Mining Precinct website as to all our programs. What I have listed here are 3 of them, which are and they listed out of the 5 because they relate to cross-cutting programs. They touch each and every other program that we have, and our aim is to find solutions to our mining challenges when it comes to mechanization, increasing or extending the life of mine, or addressing issues related to safety, productivity, or production. And so the ARTIMS program is one of the 3 that cross-cut it. So it's a huge undertaking, and so when we launched in 2017, this was the vision, this oval statement that you see here. We used that vision up until 2020 and changed course in 2021. And the reason for that is because of where we had come with our TRL levels. Now, TRL levels stands for technology readiness levels, and we have progressed much of this work that you see in this roadmap behind this block to TRL level at on average about 5, which means we were in a position now to actually go into more of the commercialization part of the TRL levels. Now, what you'll notice here, and remember when I introduced the topic, I said that our mandate was originally to look at underground communications challenges at the stope, which, if you note here, is only but one component, underground comms, of a bigger picture. So it's very integrated, and that's why we call it a unified and holistic approach. And so, given the constraints that we've had since inception, you know, budget and funding and expertise and scope, we managed to do much of this work and still maintain some integrity to the ARTIMS framework and model. Interestingly enough, the model is based on IRA, which was developed by the IIC, And Ulrich introduced the IIC to you, the Industrial Internet Consortium, and the Mandela Mining Precinct through the Artemis program has recently joined as a member, and I also now serve as a co-chair on the mining vertical. Now, I mentioned to you, shared with you the fact that our vision statement was creating a proof of concept framework for our mines, and having achieved TRL level 5 on average with all the components, it just made sense to change course to what the vision statement that you see here on the slide, which has more of a 4R flavor to it. However, we had been building up to it for the last 4 years, and now we're actually changed gear and going full on for TRL 5, 6, and so on implementations. It rests on these 3 pillars. The Mandela Mining Precinct is very much contributing towards the national imperative to develop skills. And so that's why you see the statement there of capability journey, and everything we do relates to our people, upskilling, reskilling, and developing the capability to learn, or equipping and enabling this new knowledge to be shared among the industry stakeholders, whether it's a mining company, an OEM, whoever is involved. And then obviously we will implement some solutions. We're looking for solutions. We don't want to do research for the sake of research. It doesn't even count as fundamental or academic research. It's applied research, but now the Artemis program has gone beyond that to actively looking for solutions it can tap into, but also build on and develop some other new blue sky thinking. And in the process, obviously, we will be leveraging all this hyper connectivity out there, the all sensing, the all intelligent. We will leverage as much as we can locally, but as well as globally through our new network of partners that we established this year. So just to come back to how it all fits together, the Artemis model is really a holistic and integrated components of work, system of systems, if you like, which we have brought together. These are just some of the highlights over the last 4 years that we've delivered on. And you will note there that underground communications, we did spend time on it. We have specifically chosen one of the technologies that we have proven. We've tested it on site, and there is an application for it. What we'll do in the next phase is work with Huawei. We'll implement Wi-Fi 6 where we can, and see how that works for solving some of our use cases in the mining industry. At the same time, we will be looking at some other communications protocols or technologies or implementations, those that our mining companies have come up with themselves, and we'd like to actually just go and independently evaluate those with them. And it's quite a range, and it's quite hybrid configurations and solutions that have been put together. So this is my last slide, basically, and it just emphasizes the fact that with partnerships that we've established, we can address things like underground communications more holistically. We play a role with Huawei in the IIC, as I mentioned, and we share a commonality in that we both subscribe to the IRA framework on which Artemis was based 4 years ago, and we developed with it, and specifically one for mining, which I don't know of any others in the industry per se. So that gives us a logical and progressive basis from which to actually operate together for the next few months. And so between the MMP and Huawei, we signed an MOU, and as I mentioned earlier, we will be implementing at some select sites and see how we can address some of the use cases and problems that mining faces. And that's it from my side. Thank you.
Thank you very much, JJ. I have some questions that have come through. I think I'll start with the first one.
Okay, Leandro, are you there? We seem to have lost.
Development of digital motivate them.
Leandro, we lost you for a moment, so I didn't get the full question.
Oh.
I'm looking for. I see there's a hand that's up, so I'm just going to go straight to that person who has the hand up. Is it Sie Kleko?
Yes, yes.
I don't know what happened to our host.
No, it's okay. Thanks, AJ. I hope I'm audible. Thank you very much for the presentation. And see here, I'm based at VET, School of Mining. On my previous question to the previous speaker was about the connectivity given our depth of mining, and also as we did mention briefly that we're looking at stopes, that our stopes are relatively cluttered. And in terms of communication, how are we doing in that? What we're planning it, looking at in a sense of cost and the effectiveness of communication underground, looking at the depth as well. And then the second last one will be, oh no, this is the last one. Will be, you spoke about going to 6 Wi-Fi, something like that level of Wi-Fi from Huawei. And we know that we're already skeptical about 5G. And in terms of now the human engagement, the buy-in into that, what are the measures that you will put in place to ensure that people can understand that it's not dangerous if it's not? If it is, what are the dangers associated with that level of Wi-Fi being tracked and stuff like that? Thank you.
So I'll answer the first question that I heard, and then I'll leave the second one to Ulrich, if that's okay. In terms of the safety of all these frequencies and radio waves going all over the place. With regards to the viability of Wi-Fi underground, it's very viable. I've seen it operate. It's operating at some of our mines, and it's literally at the face. A few months ago, I did a webinar from one of those sites underground. The issue here is it's not Wi-Fi or not. It's actually taking many factors into account with regards to the environment underground. And so last year we developed a tool which was meant to actually help our mining operations to decide on how they expand and deploy technology based on various factors: life of mine, mining method. It also takes into account what is your strategy as an organization in terms of expanding with this new technology and various other factors. Because one has to look at it from various sides. It's multi-layered, and then one can make a sensible decision and feasible decisions of how to expand it. We are also busy with an exercise whereby we're trying to assess the feasibility of implementing some Wi-Fi solution, or maybe even cable, and how does it relate to the bigger picture of digitalization and that journey. So definitely work on the go, and the key here is how do we relate it back to the bottom line. That is work in progress. Ulrich, you want to answer the second question? Leandro, we just took over.
Thank you. I do apologize, the internet guys. I'm sorry.
Yeah, I'm not completely sure, but I think there was one question about costs. So I cannot say anything about costs, but here I would recommend to make contact to our sales colleagues here. The other question, if I got it right, was what is the difference, or when should Wi-Fi 6 or 5G be used? And here I can say they're both wireless technologies for sure, and they have different characteristics and different features, capabilities. We from Huawei definitely see both have their individual strengths and weaknesses. I think there's not a simple rule of thumb when to use what, because you have also to look at the constraints. For example, how you want to operate the 5G network. Do you want to utilize it together with the mobile network operator? Do you want to operate it yourself? Or in the second case, do you have a private spectrum for building local networks? So there's a lot of the questions. With regards to features, I think 5G has certain capabilities in terms of real-time network transmission, specifically with the ultra-reliable low latency communication, where you can have something like down to 1 millisecond, but that's only needed for certain control operations, and only for very specific use cases like motion control, for example, for very fast moving machines. So there's no simple rule of thumb when to use what. Specifically, we see also that it could be used in parallel, leveraging the different strengths and weaknesses of each technology.
Okay.
No, thank you very much.
Thank you, Ulrich, and thank you guys for helping me out with answering some of the questions here. Our next speaker, and I'm sure many of you are familiar with him, probably some students even in here in this specific group. But for those of you who are not aware, the WITS School of Electrical and Information Engineering has been awarded electrical engineering degrees for nearly 100 years. Their educational programs have been at the cutting edge since their inception. The school provides in-depth education in engineering principles that are based on mathematics, computation, and the physical and life sciences, ensuring world-renowned graduates are versatile and well-equipped for the future, with the professional degree that is internationally accredited by the Engineering Council of South Africa. One of the highly accredited emeritus professors, and for those of you who are like me, who are not sure what emeritus means, it means retired professor. Professor Barry Dwolotsky joins us today. As an emeritus professor at WITS, his primary focus over the past 28 years has been the growth and development of the South African software engineering sector. In recognition of his contribution to the South African IT industry, Professor Barry was named the South African IT Personality of the Year and received an award for distinguished service to IT from the Institute of IT Professionals of South Africa. WITS University also presented him with the Vice Chancellor's Award for Academic Citizenship. Over to you, Professor.
Thank you. Just let me share my slides. Can I check that you can see that?
Not yet. Yes, we can see it now.
It's going to present. Whoops. Right. So after that great build-up, I feel that I'm really on the spot to give everyone a learned presentation. It might not be so learned, but it's kind of my intention just to talk a bit about this notion of 4IR, and specifically 4IR in the mining industry, or digital transformation in the mining industry, but to kind of really focus in on two things: to focus in on skills and to focus in on why and what makes digital transformation in the South African mining industry very different from many other mining sectors around the world. So firstly, this notion of fourth industrial revolution, and I'm kind of repeating stuff that was really well described by one of the previous speakers already. So thank you for setting the scene and covering some of the ground. But you know, one of the big challenges we face in this world is how we define things, and we've been bombarded in the last couple of years with this 4IR, Fourth Industrial Revolution. Many people use it, but I don't think many people have an agreed way to define it. So the two ways that people define it is they start to list a whole lot of technologies. So if you say to someone, what's 4IR? They start saying, oh, well, machine learning, AI, robotics, virtual reality, and they list technologies. But I don't think that's a very useful definition, because what's in and what's not in the list that you give. The second way people start to define 4IR is to talk about these sort of lines in the sand of history. And they say, well, the first industrial revolution was this, and the second is that, and the third is this, and now we're in the fourth. And, you know, that's a bit arbitrary as well, because why is the fourth not still part of the third? And when will the fifth come along? So I think that the definition that kind of tries to look at lines in history is quite hard to deal with. So my preference, and I'm really following on from something Ulrich said, and that's the 4 building blocks that kind of really came out of this notion of Industry 4.0 that was popularized about 10 years ago in Germany. And the 4 things that make up Industry 4.0, and I think the fourth industrial revolution, is interconnectivity, decentralized decision-making, information transparency, and digital assistance. So those are the 4 design principles that define this 4IR notion. And just to very briefly touch on each of those. So the kind of interconnectivity is everything is connected. It's the internet of everything, internet of people and internet of things. And it gives us a way to share information and collaborate. And a key to it as well is that you then need common communication standards. You have to worry about cybersecurity. And the skills that come in at this point, and I'll introduce skills at each of these points, is those skills that are around communication and the standards around communication. So if we look at how a university would prepare people for this, it's taught in things like telecommunications courses and cybersecurity courses. So it's the skill of being able to deal with connectivity. The second part of 4IR is this notion of decentralized decisions. So if you have something like a smart car or a smart mine, you don't have one supercomputer that controls everything, but you have a kind of decentralized autonomous systems that communicate at the right level, and you devolve your decision making to the correct level in a hierarchy. And for that, you would need to have the kind of skills to work with hierarchical systems. Some of the notions of machine intelligence and kind of data science fit into this kind of notion of decentralized decision making. The third part was also very well described by Ulrich, and that's the idea of digital twins. And the digital twin says that on the left of my picture, we've got the real world of real things. On the right of my picture, we've got the world of models, data, and algorithms. And you link the two via sensors and actuators. So your digital twin gives you a computer version of the real world. And a lot of the decision making and the things you do in the kind of digital twin, and then you relate that to the real world. And here you also need the skills of modeling and dealing with algorithms and dealing with data, and then communicating between the two. And the fourth building block of this is the digital assistant, or quote robotics. And this is the most controversial part of this 4R stack, because people immediately fear that they're going to be replaced by robots. And what we tend to reassure people with is that as smart as robotics is, there's still many things that robots can't do and people do very well. So we should rather see these digital assistants as ways to help people and to help do the dangerous things, the kind of messy things, the dirty things, where you wouldn't want people in any case. And clearly mining is one of those industries where you can use your digital assistants to kind of save people from dirty and dangerous work. And the skills here are the skills around mechatronics and robotics, but also AI and machine learning. So those are the skills you need. And I tend to not like this idea of fourth industrial revolution, because I tend to see the world more as an evolving digital transformation, where things build up on the previous generation of technology. And there are very few times that we leap into a revolutionary transformation. So we should be careful not to constantly see any change as revolutionary, because a lot of it is evolutionary. And the skills that we therefore need are not new skills in many cases, but we build on our legacy skills. So that's the way I see skills. The quick final things that I want to say is that the special nature of mining in South Africa, as opposed to mining in many other countries, is firstly, we mine at a very deep level. So deep level mining is what characterizes many of our, and in fact, especially our gold mines. And that throws up many problems in adopting digital and other technologies to that. Our mining has been very labor intensive, and our mines are designed to deal with labor intensive mining. So to put big robots underground and get them to do the work of people is almost impossible in terms of how our mines are designed. Our mining has a very clear impact on the environment. So there's a whole lot of stuff around the environmental impact of mining in South Africa that makes it different in some ways. And then as a colleague of mine at Wits, Professor Fred Kaywood points out, one of the things that characterizes mining, and especially our mining, is that our miners and our workers in the mining industry in many cases work blind, because although we might have great seismic models that we could run to warn of a rock burst, we kind of very infrequently provide that information, at the workplace. So one of the challenges in digital transformation is to bring information to the workplace where it can be used to improve safety and productivity. And then one of our big problems in mining is when mines close and the after effects of mining. And how can digital transformation help to support that aspect? To quickly summarize in terms of skills, I see that skills in the digital world and in most worlds is like a huge pyramid. And at the peak of the pyramid, we have the kind of experts and the people doing the advanced work. And in the mining sector, the peak skills are the same as in many other sectors. So we have to have data scientists, AI people doing IoT, people doing security. So there's nothing particularly special about mining in terms of those peak level skills. In terms of the skills lower down the pyramid, I think our challenge is to change the technology to fit the skills profiles of the users. So we shouldn't need to have to train every miner to use some technology that's not well suited to the skill of the miner. We should rather change the technology to fit the skills that we have. And that's one of our big challenges. And finally, to just put in a plug, is that at my university at WITS, we've got the WITS Mining Institute, and a very unique and a very special lab there called the Sibanye-Stillwater Digital Mining Lab, or Digimine. And under this building that is depicted here, which used to be the Chamber of Mines building, it's now the Mining Council building, and under that building is a mock-up of a mine, and a lot of interesting research there, from kind of underground communication to data flows to using drones underground is being done in that. And I think on the call we do have some people from Digimine, so I won't speak for them, but when we come to questions, they might want to chip in. So thank you, Leandra. That's my input.
Thank you very much, Professor. I have a few questions for you before we bring up the panel. I just want to remind everybody, you know, I think everyone would know that the Poppy Compliance Act came in on the 1st of July into South Africa. So our wonderful partners, the South African Institute of Mining, can't necessarily share details with us. We want to be able to share the slides with you. We want one of our, agents to be able to contact you, find out your interest in our Huawei solutions. We please ask you to complete the survey. You'll see that they've posted it in the link in the chat group. Whether you're an attendee or a panelist, we'd ask that you move over as a panelist if you can, so that you can answer or ask questions if you have questions to our speakers. Alternatively, you can complete the survey and we will contact you afterwards. So Professor, I have a question for you. When we talk about cutting edge digital technologies, it takes a process for traditional miners to embrace and master new technologies. And for mining companies, what are the practical measures to enable employees to quickly embrace and become proficient in new technologies?
So it's in fact one of the most important lessons we've had in this COVID period is how we shouldn't be afraid of technology. So for years we were talking about digital transformation and the need to train people and spend huge amounts of money on new technology and rebuild a whole organization around technology. And then in 2 or 3 days in March last year, we all went digital. And we kind of embraced digital using the technologies that were just lying around. And I think that, that it's important that we trust people and we trust the technology that we have, that people can pick up on the technologies and learn them quite quickly and easily. So kind of my feeling is not to get stuck on this idea of huge investments in technology, huge investment in retraining everyone, when it's probably going to be possible just to pick up technologies and start using them. But I'd be interested to hear with the other panelists and what the audience thinks about that.
Yes, this is David speaking.
Yeah.
I'm looking from a safety perspective. If you can get people out from the underground and you can have more people in a kind of control room where they can operate machines from off a central control point rather than having them there in harsh conditions. I mean, it's all about human life as well. So my thinking is, automation underground is something that the industry needs to look at. It might be more sufficient one person that drives 2 or 3 LHDs rather than one, but then you don't sit with the risk of fall of ground and then exposure to all the oxygen issues underground and so forth. So from a human perspective, it makes sense to look at automation going underground.
Yes,
that's also thanks.
Would completely agree with you that that's something to aspire to. I think that, and I'm in fact not an expert in mining, but people that are expert have pointed out how difficult it is to automate mining operations in South African mines. And I would be very interested to hear what other people think. But, I think that we will for a very long time, given how our mines have been designed, have people going underground to work in our mines. And then the key thing is to use technology to bring information to them that will alert them of risks and make things safer. So I think that's something to aspire to.
No, I totally agree with you.
Yeah. Can I come in? Okay, thank you. Yeah, thank you very much, Prof. And I think you have touched on the very important issue that we really do not have to train everyone into these technologies. And as Davi alluded as well, I think, and we don't have to introduce all of them, given the fact that we have already designed a mine and we have our NPVs, so continuously we try to optimize to improve the value that we generate. In full automation, it will be more possible for new operations, but those that are already that are in existence for more than 10 years or so, we just have to look and select the technology that will best suit the operation in terms of getting the information or data, translate to information, and assist in making economic decisions, whether in terms of safety and health or in terms of value economically. So thank you very much.
Thank you. Yeah, I think that's a comment. I don't think it's a question. Thank you, Sitle. You are in fact muted, Leandra.
Sorry, thank you. Thank you, Sitle. One more question, Professor, and then we'll move to the panel. I know there's a few questions from the audience. How can we support the skill development for miners? What do you think?
I think it's how we generally support skills development. I think that we have to, well, there's something really amazing in this country, and that's the BEE scorecard and our skills levy. And a lot of people pay lip service to those mechanisms. And I would really encourage people to look at what governments put in place in terms of skills development. So, I mean, companies pay a skills levy, they are scored against the BEE scorecard, and there's a strong emphasis on skills. And for people to genuinely engage in the scorecard and in skills and to do it properly. I think a lot of companies, and I hope I'm not speaking out of turn, but a lot of companies pay lip service to that. They find a way to palm off some money quickly, get the points and not bother around skills. And I think that it's very important for companies to be genuine about skills development, especially in sectors like mining.
Okay, thank you. Thank you for your refreshing opinion, Professor Barry. So I'm going to ask Ulrich and JJ to come to the screens, maybe switch on your cameras. Let's have a few questions from the audience so we can all discuss this. I know there was a question a little bit earlier on if we are DMR approved, and the answer is that we are in the process of getting DMR approved. So we should have that pretty soon. The second question was, is there any environment whereby the underground Wi-Fi is successfully deployed? And the answer is that we actually do have it successfully deployed in an environment, in the platinum environment here in South Africa. If you have any other questions and any other details, fill in the survey. We'll get your details. Someone will contact you, and we can have a discussion further on from there. So thanks Ulrich, thanks JJ, thanks Barry for joining me. For the audience, I mean, I guess you guys can unmute yourself. A lot of you are already panelists. If you're an attendee, you can move over to a panelist. Unmute yourself. Let's ask the guys questions. It's not often we have a room full of experts that can answer any questions, any burning issues that you have at the moment. That we'll be glad to answer. We have around 20 minutes for this question and answer phase. And then we'll close off. So I don't know if you want, okay, who wants to go?
Mine is a question to Prof. Dolatsky. In your presentation, when you're talking about digital skills, you talked of the lower base of the pyramid, and you were saying that it would be really wise to rather change technology to fit the skills of users. The technology, if I got you right, confirm?
I did actually lose you for a second there, but I think that you were just asking me to confirm that I thought that we should change technologies to meet the skills rather than have to uptrain everyone. And I do think that's an option.
Okay, also it's an option, not necessarily the best of things, in your opinion. I want to weigh between the two. So
yeah, I'm not sure that I'm understanding the question. Maybe could you just ask it again?
Okay, so my question is, why do you think that it's wiser to change the technology to fit the skills versus changing the skills to fit the technology?
Okay, and I should clarify, I think definitely we should constantly be upskilling people. I think the digital world is a world everyone's going to operate in the next century. So we all need to acquire digital skills. And I think that in the kind of longer term, everyone will be more digitally competent and more digitally literate. So I think we definitely should invest in digital skills. But I think that we should also meet people halfway. We should say, if we expect a miner to use a piece of equipment underground, we should design the human interface of that equipment to fit the skills the miner has, rather than give that miner something that's very hard to use if you don't have advanced digital skills. I don't know if that makes sense.
Okay, thank you. I hope you've Professor Barry's answered your question. Is there any other questions? Anybody else?
Yes, can I please come in?
Yes, please.
Yes. So just to add before I ask my question and to the panelists and everyone, just to add what Prof just stated, if you look at the demographics of South African miners, most of them are not tech savvy to a level that you want them to be. So I think Prof is trying to say that the systems we introduced in the mine should be easy for, let's say, for a matric level person or even less to use them. If you look at most softwares are relatively complex, they have a lot of features which might then affect the usage of that particular software. So if we introduce a simple software, it will be easy for people underground to use them and even understand the result. Now, going to my question, and going to the lack of skilling or lack of skills, or the skilling of people, not upskilling those who are already in operations. So we have graduates that are leaving university and they've met minimum requirement. That means they're qualified. However, they lack the practical skill. And what has been happening, and it still happens now, you go to the operation, of course, you're going to get your industry certificate so that you can practice like your blasting and so on. Now, bringing in the 4IR related requirements. Now, this is just for arguments or discussion. Will it not then be prudent that companies, after you graduate, even if during the time that you're doing your industry certificate, we don't then regard you as someone who must be adding value to the company. However, we then infuse your industry requirement that your blasting, I'm going to use the blasting because it's the first requirement for underground and surface mining, so you can be able to blast if you are in production. That during that period, with conversation with DMRE, with MQA, that we train people on these soft skills as well. Not soft skills, these tech skills as well. So that will then help them 3 years down the line. They will then not only have a blasting, but there will be people who will be able to be using these particular softwares and they'll be compatible with them. And these people I'm referring to is young generation who are relatively tech savvy in a way. Will it not then maybe in terms of what is a guideline or a policy that after graduating, as you are doing industry training, you also get equipped in techs, of course relevant to mining?
So Leandro, if I may come in there, I did put my hand up. So what he is saying is I don't have. It's valid. It's relevant. It's applicable, and that's why the Mandela Mining Precinct actually set up a program, quite unique, in addressing the people side of things, with a human-centric approach to developing, equipping, enabling our mining people to adopt new technologies, to utilize it, and the DMRE is involved, the MQA is involved, academia is involved, mining companies are involved. So I would encourage you to go and have a look at the SATCAP program. It's on the website, SATCAP standing for the successful adoption of technologies centered around people. It goes beyond traditional change management, and why it was established and how it started off was actually to try and understand what is the problem. Often we have these perceptions and we have these views, but we actually really did want to start off, and it's one of the programs that started off earlier on as well, back in 2017-18. So a lot of work has been done in that space already, and would be useful to anyone who's involved in the mining industry in South Africa.
Thank you. Thank you for answering, JJ. Are there any questions from anybody else in the audience? Somebody else who wants to put their hand up?
Hello.
Okay, so I have a question, and I think we should probably answer it. Davi had a question a little bit earlier on. I hope that Davi is still on the call. It was around the cybersecurity and how we're protecting our solutions underground. We have Kees Milan on the call. Kees is one of our senior technical leads at Huawei. Kees, are you there?
Hi, yes.
Okay, great. So do you want to maybe take the question on cybersecurity?
Yeah, look, it's a question we often get. There are various ways of attacking a wireless network, whether it be scanning attacks or web attacks or MAC address spoofing and so forth. But wireless standards do make provision for the defense of such attacks. There are wireless intrusion detection systems and prevention systems that is made capable in these wireless networks, as well as radio scanning capabilities. So the main thing we need to concentrate on is making sure that we set the correct parameters on the security profiles for these wireless networks. So it's basically two-sided. Firstly, you have to be able to get underground to gain access to that wireless network and have some form of device to connect to the network. But like I say, and I think Prof. Barry made it very clear, it's very important to have the skills. The networking skills is very important to make sure that you configure those security profiles correctly. Once those defense mechanisms are put in place, it becomes extremely difficult for these attackers to perform any form of cybersecurity. Is it still possible? Yes, it will always be possible, I suppose, but it does make it much more difficult once you've applied the correct security profiles.
Okay, thank you. Thank you for answering that case. I see Mr. Wenzel has his hand up and he's unmuted. Mr. Wenzel, do you want to go ahead and ask your question?
Yes, I just want to find out, you have spoken more about underground mining. I'm more involved in the surface mining and we still experience some challenges with network connectivities. And then just wanted to a bit find out how much or what is the size of bandwidth is expected, especially in the mining sector, to accommodate all the equipment that's expected to run on the network.
Okay, so maybe Ulrich, do you want to take that one?
I didn't get it. You talked about open pit mines, and what was the question? How long it takes to?
The connectivity challenges on the open pit mine and how those has been resolved using the technologies, especially how Huawei technology, and then the sizes of bandwidth expected for you to achieve a proper connectivity, like all your devices that are working on that network to be able to connect, because sometimes you have like data that you want to transmit from the equipment back to the office.
Yeah, so I think all technologies are there. Specifically with 5G, I think there are some new features. I can just also talk about adoption by automation industry, for example, utilizing these kind of connectivity features, and they think this is something which can be realized definitely in the next 1 or 2 years to have a really full functioning also environment to fulfill all the promises we see currently in this industry. So that's currently my view.
Okay, thank you. Is there anybody else who has any other questions? Anyone else from the audience?
Leandra, can I possibly just add to that answer from Ulrich?
Yes, please do, please.
Basically, my answer is with regards to 2 questions. The previous question, as well as the one of when do you use Wi-Fi versus 5G. So first of all, it's not a versus scenario. It's really 2 complementing technologies. In my view, 5G is more suited for open air environments where you have massive connectivity, whereas Wi-Fi is very well suited for the underground space where there's the tunnel topology is of such a nature where you have very quick signal attenuation. In other words, the signal gets lost between all the rocks and so forth. So to have these small cells in the underground space makes sense from a commercial point of view as well as a coverage point of view. For open cut mines, we have successfully deployed private LTE systems as well as 5G systems, and download speeds ranges from 50 megabits per second down up to quite a bit more than that if you go for technologies such as 5G. The small issue, if you want, that we are faced with in South Africa is obviously frequency. There's only a few operators that has 5G frequency, but once we overcome that technical difficulty, then I believe for open cut mines, 5G technology is most definitely the answer for full coverage.
Okay, thank you very much, Kees. I hope that answers your question, Wenzel. Our next, so I see I think it's Karina Giza. You have your hand up. Can you unmute yourself and go ahead and ask your question?
Thanks. It's actually not a question. I just want to add a comment in my view and experience. Prof, I completely agree with you that it is an evolution, not a revolution. And that speaks towards everything that has been discussed, the skill set, fit for purpose, etc. So what I think we need to realize is each operation, doesn't matter what type of mining you're in, you need to evaluate what is fit for purpose and what is fit for your business, and how that will affect your skills. And there will always be a hybrid. You will have, you're not going to upskill everyone. There will be some very high skilled people, and then obviously there will be people that will never get to that stage. But everything will evolve as you progress, but you need to start somewhere and progress systematically and take everyone along. I think the other challenge that we are faced in South Africa that hasn't been touched on is actually the skill sets required to deploy all these technologies, because we have a skill shortage in the technical side. So Huawei has Gijs, brilliant, but there is not so many partners that has that footprint in South Africa that can actually deliver on this. They say they can, but they can't. So just a few comments I wanted to add. Thanks.
Okay, thank you very much, Karina. Good for you, Kees. Okay, thanks everyone. I think we have maybe time for one more question. I don't know if there's anybody else in the audience. Otherwise, I have some that were put in the comment box a little bit earlier on, and I guess that this can be suited to everybody. But how can the fourth industrial revolution play a part in mining, and how does this help? So maybe we'll start with Mr. JJ.
So the interesting thing about 4IR and the journey that mining in South Africa has been on. So 2-3 years ago, we were talking about should we do it, whether, how. The how conversation wasn't quite there yet. It was whether and what does this mean. Now, COVID actually accelerated change, and as Prof. Barry alluded to, it just forced us into it, whether we liked it or not. But in terms of 4IR, stepping out and looking at 4IR in a bigger context, it's challenged all sorts of things. So I tend to look at it as a system of thinking, systems that has been challenged. And yes, we can address it to various degrees and address various components, but it's challenged things like leadership. It's challenged the way organizations have structured themselves. You know, an example of that would be a few years ago in mining, a chief data officer or a chief digital officer wasn't recognized the way it's recognized today. One of the mining companies I spoke to has reassessed its IT processes and framework and said, you know what, it's time for us to fix this. Because if we're going to get on the 4IR bandwagon or digital transformation, we need to fix things that we should have done years ago. So we start talking about the how, and this is what we're grappling with now. And we're getting answers to the how do we do this. And I just want to stop there, otherwise I could talk all day on this.
Okay, I see Karina's put her hand up again. Karina, I want to give you a chance before I close out. I think you're on mute, Karina. No? Okay, maybe it was by error. Okay, Prof, can I give you a chance to answer that question?
Yeah, I think that, you know, and I completely agree with JJ. I think it's not whether, it's how. I think that we are in the 21st century, and the 21st century is going to be dominated by digital transformation, digital technologies. And, you know, if we don't go with the flow, we won't exist. So there, you can't say that we're not going to go digital, because in a very short time, you won't exist in the world, because the world is going digital. So I think that we need to look at digital transformation as part of doing business, and we need to do it logically. I think people tend to get very hooked on technology, and technology is not the answer or the sort of problem. The technologies exist. It's how we do business in a digital world, and the mining industry is one where huge benefits can come to mining if it embraces digital. And I think the smart kind of mining companies are embracing it enthusiastically. And I think they will be the ones that are going to really dominate in the coming century. The people who lag behind and resist it will probably not exist much longer. It's as simple as that. Thank you.
Okay, well, thank you for sharing your opinion on that note. Strong close. I guess we could do this very often. It was a very good audience, a very engaging conversation. I'd like to thank the South African Institute of Mining. I'd like to thank the Nelson Mandela Precinct. I'd like to tell Mandela Mining Precinct, Wits University, Professor Barry, Ulrich, all the way from Germany. Our entire team, you know, it takes a village to make these things happen. So thank you very much, Gugu, and your team from the Mining Institute for a fantastic job. We really appreciate all the support. Please remember to go ahead and complete the survey, and we look forward to welcoming you to more events in the near future. Hopefully with the vaccine rollout in South Africa, we can see each other in person pretty soon. Thanks, everyone. Have a good afternoon. Bye-bye.
Thank you, everyone.
Bye-bye.
Thanks. Bye, everyone.
Bye.
Thank you. Bye-bye.
Bye.
Bye. Thank you, Professor Barry.